Assalamu alaikum students. Today we are going to learn about hydrostatic force acting on submerged curved surfaces. So if you have any curved surface that is basically underneath the water, so you have atmospheric pressure there, what you need to do is you need to take projections. If this is x and this is y, then you take projection of the pressure or force. So the pressure on the vertical surface is going to have same height. So height is kind of fixed. When you go in y, then the h is varying, so pressure is varying. Since pressure is varying, so the resultant force, it is going to have a line of action, and you have already learnt about finding the force where the pressure is variable. So this force is referred as Fx, and here this force is referred as Fy. Now these forces which we have made the components, it is going to have some kind of reactional forces which are being drawn here, as it is also shown in this figure. So it is going to have a horizontal component FH, it is going to have a vertical component FV, and there is going to be resultant which is FR. Now this horizontal force FH is going to be equal to Fx, and Fv is going to be equal to Fy plus W, and the resultant force Fr is going to be simply, Fh squared plus Fv squared. What about the angle? For angle, like this Fh, I can just plot it here, and this is going to be the angle theta. I just said angle theta. So this angle theta you can find out from tangent theta. Fv over Fh. So theta is basically equal to tangent inverse Fv over Fh. I hope it is clear to you. Just I repeat it again. So if you have any curved surface, no matter what kind of curve it is, if it is submerged in a liquid, what you really need to do is you just need to take the projection. You will take the horizontal projection and you take the vertical projection. So the horizontal projection or the vertical projection is corresponding to pressure at a fixed height, and here the height is changing, so pressure is changing, and then you can solve it. What if the curved surface is not behind, not under the water, but above the water, as it is shown here in this figure? In that case, what you need to do? So horizontal force is going to be same as Fx. Vertical force is going to be Fy minus W. So earlier it was Fv was Fy plus W. So the vertical force, Fy force, and the weight of the fluid, that adds up to give you vertical force when the fluid is above the curved surface. When the curved surface is above the fluid, then you need to subtract weight from Fy, and the rest formulation is going to stay the same. Resultant force Fr Fh squared plus Fv squared whole under root, and for line of action you find out tangent theta. I hope it is clear to you. What if one submerged surface is basically submerged in two different fluids? Like here one fluid is oil, another fluid is water. So what you need to do is to find out resultant force. You simply take the sum of forces. I is equal to 1, 2, whatever, in that case it is 2. So basically it is going to be Fr1 plus Fr2. And for the resultant force, just as a reminder, you know the formula. It is going to be Fr is basically P average times area, and the P average is rho G 8C times area. So if you have understood calculating hydrostatic forces on plane surfaces, then finding the hydrostatic forces on curved surfaces is pretty straightforward. You just need to take projections, horizontal projections and vertical projections, and then you add things up to find out resultant force, and to find out the angle of the resultant force you just need to take tangent. So let's do an example to further understand it. So this is an example 3.9. A gravity controlled cylindrical gate. A long solid cylinder of radius 0.8 meter hinged at point A is used as an automatic gate as shown in figure 3.36. So this is the figure which is being shown here. When the water level reaches 5 meters, the gate opens by turning above the hinge at point A. Determine, first thing, the hydrostatic force acting on the cylinder and its line of action when the gate opens. So this is the first thing that we will do. So first we need to draw a free body diagram. Free body diagram is being shown here. So this is the liquid column, and for the liquid column there is going to be horizontal force, which is equal to Fx, and the vertical force, so Fh is going to be equal to Fx. So what is going to be Fx? Fx is going to be rho g hc times A. And what is hc? It is going to be rho g. Since we are taking projection, so this part here act as a rectangle, so it is going to be S plus B over 2. Now what is S here? S here is 4.2, and B over 2 is going to be basically radius, which is 0.8 over 2. So we substitute these values here and we find out answer for Fx. For Fy, it is going to be again same thing, rho g h times A. Now if you look at this section here, this is acting like a rectangular plate which is submerged in a fluid. So the total height, which is going to be 5 meter, will give us its pressure. So in that case it is going to be simple, rho g h is going to be 5 times area. And what is going to be the area? It is going to be 0.8 meters times whatever the depth of this cylinder is. So in this way you can find out Fy. Now the next thing is we need to find out weight. To find out weight of this fluid, you need to, I just try to draw it here. So this is our cylinder like this, and that's the radius of it. I just make a rectangle here that has dimension of 0.8 and 0.8. So if we want to find out area of this green part, which is basically the weight of the fluid, then simply what we need to do is so before going through this, we know the formula for weight, which is mg, or in other words it is going to be rho g v, and v is the volume, because you know density is mass to volume ratio, so mass is going to be rho v. Now to find out rho v, we just need area, which is the cross-sectional area, times depth, whatever the depth is. And to find out cross-sectional area, I have already drawn this figure, so we need to find out this cross-sectional area, which is green here. To find out this cross-sectional area, what we need to do is we find the area of rectangle. So area of rectangle is going to be r squared, because this is r and this is r, so area is going to be r squared. So it's a square, not a rectangle. And area of this quarter is going to be pi r squared over 4. So pi r squared is the area of the whole circle divided by 4 will give us the area of the quarter. So this is the area of square, this is the area of a quarter. So we subtract this area from this area, and that will give us the area of the fluid. So area of the fluid is going to be simple r squared minus pi r squared over 4, and that multiplied with depth will give us the volume. So since we have found volume here, we know the density, we know the G, then we can find out weight of the fluid. Now the rest of the problem is very straightforward. We have found out FH, we have found out we have found out Fy, and we have found out W. So Fv is going to be Fy minus W, and then the Fr simply going to be Fh squared plus Fv squared under root, and the angle theta is going to be tangent inverse Fv over Fh. So in this way you can find out the hydrostatic force acting on the cylinder and its line of action when the gate opens. Now the second part is we need to find out weight of the cylinder per meter length of the cylinder. So when the gate is about to open, it means at that point the forces which are being applied by the fluid is equal to the weight of the cylinder. So if we can find out the moment and we add those moment up, that should give us 0 when the when the gate is about to open. So for the moment which is exerted by Fr, so it is going to be Fr times moment arm. So I just say this moment arm minus weight of the cylinder, which is basically the force, times moment arm. I say moment arm of the cylinder. It should be equal to 0. Now for the moment arm of weight, it is simple R. So it is going to be W cylinder times R minus Fr times moment arm of the Fr is going to be this component here, which is basically R sine theta, and all this is equal to 0. So when you just solve it, you find out weight of the cylinder is basically equal to Fr times R sine theta. So you know R, you have found theta already, you have calculated Fr, and then in this way you can find out weight of the cylinder. I hope it is clear to you now to find out how to find out hydrostatic force on submerged curved surfaces. If you have any questions, you can ask me now. Thanks a lot for your time. Allah Hafiz.